Okay. Hello everyone, welcome to today's class. We'll be starting with a new topic known as binomial theorem. So basically binomial theorem deals with the expansion of higher powers. Okay, you must have studied a plus b whole square, a square plus 2ab plus b square. And you must have studied a plus b whole cube also. What if you are given something more than a plus b whole cube, or suppose they give you a plus b raised to power 5, a plus b raised to power 7, then how can we solve that kind of thing? Okay, this is a cube plus b cube, 3ab bracket a plus b. So in order to solve any higher power, we need binomial theorem, and binomial theorem gives us the expansion of this. Now I don't want you to learn this as a formula, learn this as a pattern. Okay, so first of all, you start with NC0, okay, then NC1, then another term will consist of NC2, and you have to keep doing this. So I think pretty much you have the idea that this will keep going till NCN, okay, a raised, not a raised, okay, NCN. Now you start with highest power of a, so a highest power is can be n, and start with the lowest power of p. Highest power of a, lowest power of p, and what you will do is you'll keep decreasing the power of a, so a raised to power n minus 1, and keep increasing the power of p, so b raised to power 1. Decrease it by 1, increase it by 1, decrease it by 2, increase it by 2, and you have to keep doing this pattern. So don't try to learn this as a formula, it's very complicated, and keep doing this till you get a raised to power 0 and b raised to power n. Okay, this is the expansion, and this is sort of a pattern. Now the key thing that you have to see is that the sum of the power is always n. Okay, second thing, you can see that the number present here, NC0, if it is 0, b raised to power is also 0. If it is NC1, b raised to power is 1. NC2, b raised to power 2. NCn, b raised to power n. It matches with that. Okay, and the difference of them, n minus 0, is the power of a. N minus 1, power of a. N minus 2, power of a. N minus n, 0, power of a. So a lot of pattern is going on. Okay, sum of this is always n. Whatever number written here is the power of b also. Okay. What if you are given the expansion of, instead of a plus b, if you are given a minus b raised to power n? So again, I'm not giving you any formula for expansion, just the idea. You rewrite this as a plus minus b complete raised to power n. Now if you look at this, only difference with the first expansion is that instead of b, now you have minus b. So what you have to do is expand same as above and replace b with minus b. Instead of writing b, write down minus b. So minus b raised to power 0, minus b raised to power 1, minus b raised to power 2, and so on. And basically what it will do is, every time you will have odd power of b, the negative will come outside. Every time you have even power of b, it cancels out. Okay, so this is binomial theorem basically. Now one very cool expansion is regarding this 1 plus x raised to power n. If your a is 1 and your b is x, so that becomes, see, NC0, it will become 1 raised to power n, b raised to power 0, plus NC1, 1 raised to power n minus 1, b raised to power 1, NC2, instead of a, 1 raised to power n minus 2, b raised to power 2, and so on. And we have to keep doing till NCn, a raised to 1 raised to power 0 and b raised to power n. Look at the terms, b 1 raised to power, 1 raised to power, 1 raised to power. See, 1 raised to power anything is always 1. That means there was no purpose of writing this, so remove it. So what you get? You get basically nc0 b raised to power 0, nc1 b raised to power 1, nc2 b raised to power 2, ncn b raised to power n. Okay. So I'm going to rewrite this now so it doesn't look so weird. Okay. So nc0 b raised to power 0, nc1 b raised to power 1, nc2 b raised to power 2, ncn b raised to power n. Oh sorry, b was x now actually. Oh, sorry. So instead of b I have to write x. So basically you keep on increasing the power of x, that's it. You don't have to deal with n. X raised to power 0, x raised to power 1, 2, 3 and x raised to power n. Same with minus also. For minus, what will happen? See, instead of x you will have to replace it with minus x. So nc0 minus x raised to power 0. Okay. Achha, x raised to power 0 is already 1, so won't make a difference. Okay. So this becomes minus x raised to power 0 plus nc1 minus x raised to power 1, nc2 minus x raised to power 2 and till ncn minus x raised to power n. Okay, like that. So this pattern, see if you look at the pattern, what is so important about this? You see the power of x, they are increasing, x raised to power 0, 1, 2, 3 up to n. Okay, this will help you once in a question, very specific one regarding the summation. Plus it's cool to know that if the first term a is 1, all you have to do is keep increasing the power of x and keep increasing nc0, nc1, nc2. Okay. Now let's see a question how to actually expand this. So this time this is your a, that's your b. You need to do the expansion of this and the power is 6. Okay. So before even starting, we need to have nc, and this is our n na? So we have to calculate nc0, nc1, 2, 3 up to n. So basically we have to calculate 6c0, which by the formula nc0 is always 1. Then you have to calculate 6c1, but with the formula again nc1 is always n, that is 6. 6c2, I told you how to calculate this. 6 into 5, write down two numbers, okay, and divide by 2 factorial. So that's 30 by 2, 15. 6c3, write down three numbers backwards, 6 into 5 into 4 and divide by 3 factorials, which is 6. So that's 20. Okay. Now comes 6c4. So basically if you look at 6c4, if I use the property NCR was NCN minus R. If I use that property, what is 6c4? 6c4 is the same as 6c, 6 minus 4, that is 6c2. So that means this is also 6c4. So I don't have to calculate again. Similarly, if you calculate 6c5, okay, 6c5. So it is 6c, 6 minus 5. What is 6 minus 5? 6c1. So that is 6c5. Similarly, 6c6 is also 1 by using the property. So as such, we needed only these values. Okay, 6c0 is same as 6c6, 6c1 was same as 6c5, 6c2 is same as 6c4, 6c3 is equal to already 20. And again, even if we subtract using this property, 6c3, 6c, 6 minus 3, that becomes again 6c3. Okay, now that we have the values, so it will be easier to expand. Let's do the expansion. So we'll start with 6c0, x is our a, so we have to start with the highest power of this 6, and the second term 1 by x we have to start with the 0 power. Now after that use the pattern 6c1, okay, decrease the power of x, increase the power of 1 by x. 6c2, decrease the power of x, power 4, and increase the power of 1 by x, 2. 6c3 x raised to power, it will become 3, 1 by x raised to power also 3. You can use the other property also, like 6c4. The first term power is subtraction of these two. 6 minus 4 is 2, and 1 by x is the second term. Second term power is same as this, so power 4. 6c5 x raised to power 1, 1 by x raised to power 5, and finally 6c6 x raised to power 0, 1 by x raised to power 6. Okay, so of course a lot of terms in the expansion. Okay, that's all. Let's put down the value of this 6c0, 6c1, 6c2, 3, 4, 5 and 6. We have already calculated that. So 6c0 is 1 into, this is x raised to power 6 plus 1 by x raised to power 0 is 1. 6c1 was 6, x raised to power 5, and this is 1 by x. So power 5 and then denominator is only x. So x will cancel. So effectively you'll have x raised to power 4. You have to solve the power of x also. 6c2 was 15. So x raised to power 4 and 1 by x raised to power 2. So power cancels again, 4 minus 2 becomes 2, plus 6c3 is 20. X power 3 in the denominator they will in the denominator this is x raised to power 3, this is also x raised to power 3, they will cancel each other, so no power of x, so only 20, plus 6c4 again is same as 6c2, which is 15, x raised to power 2, x raised to power 4. This time again if I cancel it, power becomes 2 minus 4 minus 2, which is square in the denominator basically. 6c5 is same as 6c1, that's 6 into x raised to power 1 upon x raised to power 5, that becomes x raised to power 4. Lastly 6c1 is 1 into x raised to power 0 is also 1, 1 by x raised to power 6. That's it. So if we write this properly, so x raised to power 6 plus 6x raised to power 4, 15x square plus 20 plus 15 by x square plus 6 by x4 plus, this is 1 multiplied na, so only 1 I'll write, otherwise it look like x, plus 1 upon x raised to power 6. That's your answer. Okay. This is what you have to do in the proper expansion. Of course they'll not ask you for this in any objective sort of a question, but what they can do is they can ask you what is the 5th term, what is the 7th term. So what you can do is you can open it, but it's a lengthy process. There is a better way to find a particular term. Like if you look at the order, you can see this is the 4th term na? And somehow this is independent of x, means there is no x present. There is a better way to find this that we'll study in few minutes, like after solving few questions we'll study about this. Okay, or they can ask you what is the 2nd term, what is the 4th term, whatever they can want to ask. So that we'll deal with later, but let's first understand how the expansion works. I hope it is clear. Now let's look at a question in which negative power comes. Okay. So for negative power, I told you rewrite this as 2 by x plus minus x by 2, and then power is 5. So power 5, that means we have to start with 5c0, 5c1, 5c2. See, 5c0 is 5c5 also. Use the property. NCR is NCn minus r. So 5c 5 minus 0. 5c 5 minus 1 is 4. 5c2 is 5c3. So we have to basically calculate these three. Let's calculate 5c0 using the property. NC0 is always 1. NC1 is always n, so 5. NC2, so 5c2 let's calculate. So write 2 terms backward, divided by 2 factorial. So that's 10. That's it. Now let's use it in the expansion. Let's expand from here. 5c0, 5 is actually small like this, sometime it becomes bigger. So 5c0, start with the first power, 2 by 5, 2 by x raised to power 5 minus x by 2 raised to power 1, sorry, not 1, 0. Then 5c1, power decreases, minus x by 2, power increases. So power has to be total 5, plus 5c2, 2 by x power 3 minus x by 2 power 2, plus 5c3, 2 by x power 2 minus x by 2 power 3, 5c4, 2 by x power 1 minus x by 2 power 4. Okay, one power decreases, one power increases, like that. Lastly 5c5, okay, power 2 by x power 0 minus x by 2 power 5. It's very much complicated at the last. Okay, let's start from here. Let's put down the values. 5c0, 1, 2, 3, 4, 5. Okay, 5c0 was 1. Let's solve simultaneously. This is 2 raised to power 5, so 32 upon x raised to power 5. Okay, anything raised to power 0 is also 1, so that's your first term. Second term is 5c1, that's 5. 2 raised to power 4 is 16 upon x power 4 into minus x by 2, plus third term is 5c2, which is 10 into 2 cube is 8, x cube into square of a negative term is always positive, so negative will cancel out, so that will become x square by 4, plus 5c3 is also 10 into 2 square is 4 upon x square into negative cube is negative, so minus x cube by 2 cube is 8, plus 5c4 is again 5 into 2 by x into, again power is even. Whenever the power is even for a negative term, that becomes positive, so x raised to power 4 power 2 raised to power 4 is 16, plus 5c5 is 1, 2, anything raised to power 0 is 1, and lastly minus x raised to power 5 will be minus x raised to power 5. Okay, negative means odd power of any negative number is negative, na? So that's when this negative power of 5, x raised to power 5 and 2 raised to power also 5, that's 32. Let's solve few bits. First one becomes 32 by x raised to power 5, plus next becomes, this will cancel, 2 and 16, 8, 8, 5, 40. So 40, and first this term instead of positive it will be actually negative, na, because of this negative, and x and upon x raised to power 4 it will become x cube in the denominator, plus next term is 4, 8, it will cancel, so 20, and x square x cube, so in the denominator only x, plus again this one will cancel, 4, 8, 2, 2 and 10, it will become 5, but in not positive it will become negative. Okay, positive negative is negative, so minus 5, and x square x cube will cancel, so minus 5x, plus this will become 5 by 8, x and x raised to power 4, it will become x raised to power 3, and last term that's will be also negative. Okay, x raised to power 5 by 32. That's it. That's the expansion. See, it will never happen like these terms will be further simplified. It's just that they can be solved individually. Means each term will get solved. That's it. You don't have to worry that further they will get solved or not. They will not, because each term is different. Okay. You can see there are like odd powers of x only, not even power of x. All right. Now there's one type of question. Basically, it deals with kind of a sense. He's asking you the expansion of this. Find this x plus 1 raised to power 6, x minus 1 raised to power 6. Okay. And you have to add them. So if I do the expansion of the first one, I will take the whole space so that we don't run out of the space. X plus 1 raised to power 6. Okay, now it will become, start with 0, 6c0, x raised to power 6. I'm not writing 1 raised to power because you know 1 raised to power anything is 1. So I'll write only this. So 6c0 x raised to power 6 plus 6c1 x raised to power will decrease, 1 raised to power same. 6c2 power again decrease, 6c3 power again decrease, 3, 6c4 x raised to power again decreases, 6c5 power again decreases, 6c6 x raised to power 0 again 1. So writing this expansion was easy. X minus 1 treated like x plus minus 1 raised to power 6. Now think, start with same 6c0 x raised to power 6 minus 1 raised to power 0. Anything raised to power 0 is 1. So let's remove that. Plus 6c1 minus, sorry, not minus, x raised to power 5 minus 1 raised to power 1. So odd power of -1 will be negative. Okay. So negative will come here. So remove it. That's it directly. Then again 6c2 x raised to power 4 minus 1 raised to power 2. Again even power of negative number is positive. So plus 1. So remove it. Then 6c3 again odd power of -1 will again come. Definitely this term will be negative, and you can see a pattern that in the expansion of an a minus b form you will have alternate plus minus sign. So plus minus plus then again minus. Pretty much you can sense the next one. Plus minus plus, like that. Okay, and you have to add them. So let's add them. So the benefit of writing that like this was, now positive negative will cancel, positive negative will cancel, positive negative will cancel. So basically you will have these terms which are pretty much same. So you will add them directly. So it will become 2 times. So it will become 2 times 6c0 x raised to power 6. Then another term will also have 2. So we can take the 2 common from the whole expansion. 6c2 will also have 2. I have taken 2 common. 6c4 will also have a 2 because of the addition, x raised to power 2, and 6c6 will also have the addition. Now you solve the value of 6c0, 6c1, 6c2, which we have already solved, so I'll put down directly. So 2, 6c0 is 1, so x raised to power 6. 6c2 was 6, 5, 30, 15, x raised to power 4. 6c4 was same as 6c2, so 15 x square. 6c6 is 1. That's it. Write less, think more. Okay, in MCQ specifically, try to avoid try to write as much less as possible and try to think, because if you keep writing each step properly, you'll never be able to finish the exam. All right, same thing, is just that instead of adding those terms, now you have to subtract, and this time this is not 1. So yeah, this time you'll have to write both the terms. Okay, but we know now that instead of plus, if there is minus, a minus b, so we will have alternate plus minus terms. That's the effect of negative. Okay, so we'll not worry about like what happens with minus b. Let's solve that. Okay, so let's write first expansion of a plus b 4 power 4. So 4c0 a raised to power 4, and 1 second. Yeah, So we were doing like a plus b raised to power 4 na. So 4c 0, start with a raised to power 4, b raised to power 0, 4c1, a raised to power 3, b raised to power 1, decrease, increase, 4c2, decrease, increase, decrease, increase, 4c3, power of a decreases, power of b increases, 4c4, power of a decreases, power of b increases. Okay, that's it. We'll not solving any further. Then you have a minus b raised to power 4. Now we already know what this does. This makes alternate term negative. So we'll start with a positive term. Then you will have a negative term. Then again you will have a positive term. Then you will have a negative term. A raised to power 1, b raised to power 3, and then again you will have a positive term. Okay, that's the only effect of negative, because you can see odd power of b, odd power of b, sorry, odd power of b, that will make minus b raised to power 1 minus b raised to power 3, that will make term negative now. Okay, now we have to subtract. For subtraction we have to change the sign. So this positive becomes negative, negative becomes positive, positive becomes negative, negative becomes positive, positive becomes negative. Now add them, cancel, this also cancel, this also cancel. So effectively you are left with only two terms, 4c1 and 4c3, and so that will become 2 times. So 2 times 4c1, a raised to power 3, b raised to power 1, plus again 2 times 4c3, so I'm taking 2 common, so 4c3, a raised to power 1, b raised to power 3. Okay. All right, this is done. Now let's put down the value 4c1. NC1 is always n, that's 4, and if you use the property 4c4 minus 1, that becomes 4c3. So both are 4. So 4a cube b1 plus 4a b cube. If you take 4 common, it will become 8. If you take ab further common, it will be a square plus b square. This is the simplified expression that you can get. Okay, all right. Next is this summation. First of all, you have to understand what is this symbol and how it works. Summation means, the name is summation, okay, and summation means addition. Now what do you have to add? You have to add this expression, but you have to put the value of r as 0, then r is 1, then r is 2, then r is 3, and keep doing this till you reach n. This is the meaning. Okay, the lower value defines from where you have to start. So we have to start from putting the value of r as 0, then increase it, r1, 2, 3, and we have to reach till n. So I'm just rewriting this. So I'll write NCR first and 3 raised to power r later, and then summation r equal to 0 to n. So this means we have to add, we have to first put 0. So NC0, this becomes 3 raised to power 0. Then add, then put r as 1, NC1, 3 raised to power 1. Then again put NC2, 3 raised to power 2. Keep putting the value till you reach n. 3 raised to power also becomes n. Now I told you that one simplified expression will help you a lot. Remember, the power of x was increasing in 1 plus x raised to power n was NC0, x raised to power 0, NC1, x raised to power 1, NC2, x raised to power 2, and this is pretty much looking like this same expansion, NCn, x raised to power n. You can see it's like x is 3. So that means this whole expression can be rewritten as, this is nothing but 1 plus 3 raised to power n, which is 4 raised to power n, and this was the question that you have to prove that this expression was, this was a 2 proof question that proved that this expression was 4 raised to power n, and we have proved it. Okay, so relating it with this is simplifying this question at a higher level. but you have to think about this first of all. That remember that pattern, that nc0 x raised to power 0, nc1 x raised to power 1. This is the expansion of 1 plus x raised to power n. If you can judge this format, it's very simple. Okay. Okay. Now from application point of view, let's see a few application. Okay. Okay. So what you can do is you can solve 101 raised to power 4 like this. Okay, something like you used to do na. Suppose earlier you used to do like calculate 99 square. So what you would do is like 100 minus 1 whole square and then use the property, or 101 square was asked, so you used to write 100 plus 1 whole square, a plus b whole square. Same thing we have to do here also. I'll rewrite this as 100 plus, not 100 plus 1, I'll write it as 1 plus 100. Why? Of course you know why. Because it will look like 1 plus x raised to power n, and that is very simple to solve. Okay, so 1 plus 100 raised to power n. So we'll start with 4c0, 100 raised to power 0, 4c1, 100 raised to power 1, 4c2, 100 raised to power 2. Let's erase it, create some space, you get the idea. 4c3, 100 raised to power 3, 4c4, 100 raised to power 4, and that's it. So let's calculate 4c0, which is same as 4c4, which is always 1. nc0 is always 1. Then 4c1 is same as 4c3. So 4c1 is always 4. 5c1 is always 5. 6c1 is always 6, like that. And we have to calculate only 4c2. So write down 2 terms backward, 4 and 3 divided by 2 factorial. That's 2. So 4, 3 are 12, divide 2, 6. That's it. So now put down the values. So this becomes 1 plus 4 into 100, so 400, plus 4c2 is 6 into 100, so 0000, plus this is again 4 into 0000, okay, plus 000000 4 times. Now you have to add this. So my recommendation, don't try to do this fast, do the alignment 1 0 0 0 0 0 0, then 3 times 00, so 4 3 times 00 00 00, then 6 2 times 00, then 4 100, and then 1. Now add them, 1 401 604 4010. So that becomes 104060401. Okay, that's the answer. Of course, like if you don't want to do that and suppose the question asks, you can literally multiply also, but this is one application, this is how you can do. And point is, suppose they can give you power 5 also, power 6 also, then I think multiplying it 4 5 times, it will become very complicated and there is a risk of making error. However, if you use this becomes simple. Another application is checking which one is greater. Okay, so look at this. It's saying that using binomial theorem indicate which one is which number is larger, 1.1 raised to power 10,000. So we have 1.1 raised to power 10,000 and another one is 1000. Now just try to think which one is greater before even solving it, just by your common sense. I'm not even common sense, just guess it and let's see. Okay, so this can be rewritten as 1 plus 0.1 complete raised to power 10,000. Of course, we are not going to write the whole expansion of it, but look at the idea. It's like 1 plus again x raised to power n. You can see the benefit of writing like this. So we have to start with 10,000 C0 0.1 raised to power 0, 10,000 C1 0.1 raised to power 1, and so on. Of course, a lot of terms are there, but not going to solve each and every term. Let's look at the first. Anything C0 is always 1. Anything raised to power 0 is also 1. So first term is 1 plus 10,000 C1. And C1 is n. So 10,000 into 0.1 plus, and so on. The terms will continue, of course. This becomes 1 plus 10,000 into 0.1, that becomes 1000. This already becomes 1001 plus something. Definitely it will be more than 1000. So I can say yes, this one is larger. Okay, so don't have to do the whole expansion. Just by writing only the first two terms, pretty much you can guess. Okay, all right, that was the simple gist of your binomial theorem. Now, one of the most important topic of binomial is general term. Understand how to write general term, then applications, lot of applications. Find the fourth term, find the fifth term of the expansion, term which is independent of x, find the power of x raised to power 4, whether it will exist or not. Everything can be answered with the help of a general term. Okay, let's understand general term now. Before solving any question, let me give you the idea first of all. General term. Okay, so it is represented by TR plus 1. First of all, T means term. You will have first term, so we'll call it as T1, then T2, then T3, T4, and so on. So in general, we'll call it TR plus 1, and the formula for that is NCR A raised to power n minus r, b raised to power r. It is pretty much following the same rule. I told you that the same power will come here, and the subtraction of these two will be the power of a. Okay, so that's the formula of oh sorry, highlighter now. Box. That's a formula for general term. Now let's understand only how to write the general term. Okay, then we'll see the application. Okay, he's saying write the general term of this expansion. A is x square, and you rewrite this as, first of all, x square plus minus y complete raised to power 6. So this is your A and this is your B. Okay, let's write down the general term. So general term TR plus 1 is equal to n, we know. Okay, n is 6, so 6CR. Of course, it will be in terms of r because you don't know r right now. A is x square raised to power 6 minus r, and B is minus y raised to power r. Okay, now what you have to do? You have to use the properties of exponents to separate each and every term and simplify as far as possible. So 6CR, power raised to power, it will multiply it. So x raised to power 12 minus 2r. And I can rewrite this as AB raised to power n is A raised to power n, B raised to power n in the exponents. So I'm rewriting minus y as minus 1 into y complete raised to power r is there na. So I'm using the same property, so it will become minus 1 raised to power r, y raised to power r. Okay, I've used this property. AB raised to power n is A raised to power n, B raised to power n. Power can be distributed regarding multiplication. Okay, that's it. That's it, writing general term. Of course, the question will never ask you to write general term. He'll use the application part, but let's solve first. So that was the solution for the third question. Let's solve the fourth one also, numbered fourth. Okay, again we have to write the general term, so I'll directly say TR plus 1 is, let's see the power first of all. N is 12, so 12CR. Okay, then first term is x square raised to power 12 minus r. You know what you have to do for this. And then second term is minus yx complete raised to power r. Now this time it is not only minus y, this is yx. Let's simplify. 12CR, let it be as it is. Power raised to power, you can solve this. Okay, solve it. What do you get? x raised to power 24 minus 2r. I'll tell you why this is important to generate separate powers. Then this becomes minus 1 raised to power r, y raised to power r, x raised to power r. Distribute power r to every term, minus 1, y and x. And now it can further be solved by combining these two terms. Okay, so 12cr, okay, x raised to power something, x raised to power something, they are in multiplications, so power gets added, so this becomes x raised to power 24 minus 2r plus r becomes minus r, and then minus 1 raised to power r and y raised to power r. That's it. We cannot solve any further. This is the maximum simplified general term we can generate. Now let's look at the application part. Okay, so for this question, he's saying find the fourth term. So what we can do is literally expand it and see the fourth term, or we just directly find the fourth terms. That means we need T4, term 4. I can rewrite this as T3 plus 1. Now the reason is to get the value of r. Compare it with TR plus 1. You can see r is 3. So we have to put the value of r as 3. We'll put it later. First, let's write down the general term, TR plus 1. Same thing, you have to first write the general term. So 12C0, sorry, not 0, 12CR, x raised to power 12 minus r, and minus 2y raised to power r. And you have to put the value of r as 3. What you can do is you can literally simplify it and then put the value of r as 3, or you can directly put the value of r as 3. So putting r as 3 to get T4. So you'll get T, if you put r as 3, so 3 plus 1 becomes 4. So T4, 12C4, x raised to power 12 minus r. So 12 minus 4, which is 8, and minus 2y raised to power 4. So 12C4, it will be a bigger value. I'm not solving. You can pretty much solve this on your own. X raised to power 8 minus 2 raised to power, this is even, so it will become positive. So positive 2 raised to power 4 is 16, y raised to power 4. 12C4, if you want to calculate, you can calculate like this. Write down 4 terms backward, 12 into 11 into 10 into 9, divided by 4 factorial, which is 24, 2, 5, so 45 into 11, 45, so 495. So 495 into 16, you have to solve 495 into 16, x raised to power 8, y raised to power 4. This is the coefficient basically. Okay. Not solving the multiplication, you can solve. Okay. Same idea, different term, different values. You have to find the 13th term. Okay. So for 13th term, first decide what will be the value of r. T13 you need. It can be rewritten as T12 plus 1. That means now you compare it with r. So you get r as 12. So basically r is always 1 less. You don't have to do every time this. Basically r, if he is asking for 13th term, r is 12. If he is asking for 5th term, r is 4. Okay, r is always 1 less than the term he is asking. So first we need general term TR plus 1. So 18CR. Oh, this time so you'll have to calculate 18C12. Okay, anyway, 18C. Let's calculate first this. Of course, from MCQ point of view, you will not get these kinds of long question, but from subjective point of view, you will get. And that matters because in subjective you do have time. So 18CR, first term is 9x complete raised to power 18 minus r, subtraction of this, and then second term minus 1 by 3 root x. Okay, this one is slightly complicated. Complete raised to power r is like this. Okay, now you have to put again, what you can do is you can further solve this or what you can do is you can directly put r as 12 and then solve. Okay, I know that solving in terms of variable is always complicated, so preference will be towards putting the value and then solve. So let's solve by using your method. 18c12, 9x raised to power, if you put 12, so it will become power 6 and minus 1 by 3 root x complete raised to power 6. Sorry, not 6, 12. Okay. 18c12, let it be as it is. 9x raised to power 6, it can be broken down as 9 raised to power 6, x raised to power 6. This negative raised to power even power, it will be positive, so 1 upon 3 raised to power 12 root x raised to power 12. So basically root x means x raised to power 1 by 2. So x raised to power 1 by 2 power 12. I'm showing you steps. Okay, 1 by 2 power 12. 18c12. Rewrite this as 3 raised to power 2. So 3 raised to power 2 raised to power 6, x raised to power 6. Denominator is 3 raised to power 12. This becomes power raised to power, you will multiply, so in the denominator you will get x raised to power 6. Oh, good. X raised to power 6, x raised to power 6 cancels. Okay, something has happened. Good. 18c12. This becomes 3 raised to power 12. Denominator is also 3 raised to power 12. Okay, so that also cancels. So effectively your answer is 18c12. You may get this as an option, like 18c12. But further you can solve this if you want the exact value. Write down, don't write down 12 terms. My recommendation is use the property, like 18c12 is same as 18c, 18 minus 12, which is 18c6, and now use the idea that I told you. Write down 6 terms backward and then divide by 6 factorial. Okay, again, not solving it, you can solve. That's for my sake, this is the answer. Okay. Okay, now what you can do is, so far you have found a particular term. What you can do is find the coefficient of a particular power of x in the expansion also. Let's see how that can be done. Okay, another application, 2 questions, so let's take some more space and divide it also in 2 parts. Okay, let's solve the first one. It's saying find the coefficient of x raised to power 5. So remember that finding the coefficient of a particular term is also regarding the general term. Write down the general term first of all. Tr plus 1 is 8cr. First term is x, so x raised to power 8 minus r. Second term is 3 raised to power r. Okay, now what do you need? You need x raised to power 5. And what is the power of x right now for you? 8 minus r. So somehow this 8 minus r should become 5. So we can generate the condition directly. 8 minus r should be 5. That gives you r as 3. Now that you already know this is r as 3, just put down the value in this expression. So this becomes 8c3 x raised to power 8 minus 3 and 3 raised to power 3 raised to power, this was r, so 3 raised to power r was 3. Okay, 8c3, so use the same idea, 8 into 7 into 6, 3 terms backward, divided by 3 factorial, which is 6, cancel it, x raised to power 5, 3 raised to power 3 is 27. So multiply it now. 8 7s are, you will get 56 into 27 into x raised to power 5. The coefficient is the multiplication of these two, 56 into 27. Okay, again, not solving the multiplication, you can solve that. Second question. you have to find the coefficient of a raised to power 5, b raised to power 7. So same idea. First of all, always write the general term. So that is, power is 12 na? So 12 CR a raised to power 12 minus r minus 2b raised to power r. Let's simplify it slightly because we need the power of a and power of b na? So let's separate them. So 12 CR a raised to power 12 minus r. Using the property of separation, you can rewrite this as minus 1 raised to power r, 2 raised to power r, b raised to power r. Now compare it with a raised to power 7, sorry, not a raised to power 7, a raised to power 5 and b raised to power 7. Even if you compare this, you will get 12 minus r as 5, that gives r as 7, and even if you compare this directly, you get r as 7. Okay. By comparing this also, you directly get r as 7. By comparing this also, you get r as 7. So even if some complicated expression is there, don't worry. You have to compare only one of the power of the variable and you will get the value of r. You compare it with anything, by a also, by b also. I'm just showing it to you that whether you compare it with a or b, still you're getting the same value of r. Put the value of r now. So that gives 12 C 7 a raised to power, of course it will become 12 minus 7 5, and minus 1 raised to power 7, 2 raised to power also 7, b raised to power 7. So answer will be, negative power is odd, so negative 12 C7 and 2 raised to power 7, it will be a larger value, and a raised to power 5, b raised to power 7. Coefficient will be this term minus 12. So suppose you have only one option negative, so you can directly judge then. So this is the coefficient. Okay, 2 raised to power 7, 128. You can then multiply it by 12 C7, calculate that. Okay. Now one more application, that is regarding middle term. But before that, I need to explain some concept of middle term first of all. You need to note down this. See, we are expanding about power n. Now power can be even or power can be odd. In the case of even, you have actually if you are doing power 2, you get 3 terms. If you do the power of if you do the expansion of power 3, you get 4 terms. So every time you are doing power expansion of any particular power, you get one more term. So if you are doing power n, which is even, you will get n plus 1 terms. So you will get odd number of terms. In odd number of terms, you will have one middle term in between, and that middle term, the concept is for middle term. So in the case of n being even, you will have one middle term, that is n by 2 plus 1 th term. Basically th means this 4th, 5th, 7th, 8th, something like that. Okay, remember, this is not the answer. This is just telling you that which term will be the answer, t4, t5, t7, something like that. Okay, in the case of odd, you will have even number of terms in the expansion. In even number of terms, you will have 2 middle terms. So n is odd, expansion has even terms, so 2 middle terms. One is n plus 1 by 2th term, and the other one is n plus 1 by 2 plus 1, means whatever term you calculate here, you add one more. Okay, fine. Let's see with the help of a question, and then we'll see how to calculate that. So first of all, let's solve this one, 8th one. Okay, n is 10, that's even, so one middle term. and that will be n by 2 plus 1th term. So that is 10 by 2, that's 5 plus 1th term, that's 6th term. What is the meaning of 6th term? He is saying T6 is the middle term of this expansion, and we can find a particular term of expansion by using the concept of general term. Okay, so if I ask you to calculate 6th term, you can calculate this now because I explained you just how you have to do. So T6, that means R will be 1 less, R will be 5, so TR plus 1, use that, 10CR x by 3 raised to power 10 minus R and 9y raised to power R. Of course, since the values are bit typical, so it will be a large, it will take slightly more time to calculate. Put the value of R as 5, so 10C5, that will take some time to calculate, x by 3 raised to power 5. This is sort of a subjective question. Objective will have simple terms, and 9y raised to power also 5. Same way you have to distribute. I will give you the answer in terms of 10C5 only. X raised to power 5, 3 raised to power 5, 9 raised to power 5 will become 3 raised to power 10. Use power of power concept, 3 raised to power 2 raised to power 5 and y raised to power 5. So this become 10C5. This power, these two terms are in division, so power gets subtracted. So 3 raised to power 5, x raised to power 5, y raised to power 5. Okay, you can further solve this 10C5. That's the overall idea what you have to do. So for middle term, first you have to decide which term you have to find. Okay, let's now do the one for the odd also. Seventh, 3 minus x raised to power 3 by 6 complete raised to power 7. Okay, you have to find the middle term. So first thing, n is 7, that's odd. So for odd you will have two middle terms. One is n plus 1 by 2th term, and then is 1 by 1 plus 1 by 2 plus 1 more. So 7 plus 1 by 2, that's 4th term. Okay, and then one more of that 5th term. So 4th and 5th term will be the middle terms of this. So you have to calculate T4 and T5 for this expression, which I think pretty easily you can calculate. Okay. Okay. So this time I'm not solving it. You get the overall idea. You can calculate. One more application is regarding independent term. So for that, let me give you one simple meaning. Independent of x means a term without x, which means that the power of x will be 0, x raised to power 0. That's the overall idea. Now let's see how to solve these kinds of questions. For MCQ point of view, these are very important. Independent terms. Okay. Let's see. It's saying find the term independent of x in the expansion of this expression. So we'll not calculate by using the whole expansion. What we'll do is use the concept of general term. Let's round down the general term. TR plus 1 is NCR, so 6CR, that's your n. Then first term A, 3 by 2 x square complete raised to power 6 minus r. And then second term is minus 1 by 3x, slightly complicated, raised to power r. Separate the powers. 6cr. This 6 minus r power will be distributed to each and every term. So I'm writing 3 raised to power 6 minus r, 2 raised to power 6 minus r, x square raised to power 6 minus r. So power raised to power will get multiplied. So 6 to the 12 minus 2r. Okay. I have distributed 6 minus power r power to each term. Same thing you have to do here also. Minus 1 raised to power r, 3 raised to power r, x raised to power r. Now focus on power of x. Don't solve anything else. If you want, you can, but don't solve right now. Copy everything else. So 6cr. I think we can solve power of 3 also. So let's solve it. 3 raised to power 6 minus 2r. Even if you don't solve it, doesn't make much of a difference. 6 minus r. X minus 1 raised to power r is also there. Minus 1 raised to power r. And x raised to power, they are in division. So power will get subtracted. So 12 minus 2r minus r. So that becomes 12 minus 3r. And for the independent, this power has to become 0. Because in order to get a term independent of x, this power of x should not exist. That means 12 minus 3r should be equal to 0. That means r should be 12 by 3, which is 4. This is how you get the value of r. And now put r as 4. So we already know this will become x raised to power 0. So just solve for this. 6c4. 3 raised to power 6 minus 2r becomes 8 upon 2, 6 minus r is 4, and minus 1 raised to power also 4. Now let's calculate. Let's get some space. So that becomes 64 is same as 6c2, 66 minus 4, because expansion will be easier. This becomes 3 raised to power minus 2. This becomes 2 raised to power 2. This becomes positive 1. So 1. 62 is 6 into 5 by, write down 2 terms backward, divided by 2 factorial. 3 raised to power minus 2 is 1 by 9. 2 raised to power 2 is 4. So 30 by 36 by 2. Basically this becomes 15 by 36. So that becomes 3, no? 5 by 12. That's your answer. Let's see. Okay. By solving this, I'm getting 5 by 12. Okay. So the independent term is 5 by 12 in the expansion of this. Judging r is more important. Remember that. How to get r. Okay. Power of x should become 0. Okay. One more question. Pretty much last one. Independent of x again. Last application is there, no? So pretty much this will be the last question. Again, same thing we have to do. We have to find the term independent of x. Basically, we have to get the value of r for which x raised to power becomes 0. This time cube root of x is there. That means x raised to power 1 by 3. This is also cube root. So x raised to power 1 by 3 in the denominator. Let's write down the general term. Tr plus 1 is 18c r. First term x raised to power 1 by 3. Complete raised to power 18 minus r, n minus r. Second term is also positive, so okay, you don't have to deal with negative. 1 by 2 x raised to power 1 by 3 complete raised to power, it will become r. Let's separate them. 18cr, power raised to power, you will have multiplication, so x raised to power 18 minus r by 3, okay, multiply by 1 by 3. This will become 1 by 2 raised to power r, x raised to power r into 1 by 3 becomes r by 3. Okay, so 18cr, again solve for the power of x, this one and this one. combine them. So this becomes, they are in division, so power gets subtracted. So 18 minus r by 3 minus r by 3, that, and 1 by 2 raised to power 3 as it is, 2 raised to power r as it is, 18 cr, 1 by 2 raised to power r, x raised to power 18 minus 2r by 3. This is what we need to generate. The power of x should become 0. That means 18 minus 2r should be 0. That means r is 9. That's it. Now put r as 9. First I have to get the value of r for which the power of x becomes 0. So if we put r as 9, so 18c9, 1 by 2 raised to power 9. That's your answer. Not getting the exact value because it depends, like the question may give you answer in terms of c also. Of course, they are not going to give you a question for such a long calculation in objective anyway. Okay, fine. So these are the applications of binomial theorem. The applications are much more important, means the second part that I explained, independent term, coefficient, middle terms, yeah, and particular term, 13th term, 4th term, 5th term, that is much more important rather than the whole expansion. Okay, so do practice this. Okay. All right, fine. That covers your topic for today. That ends the chapter also for this. We'll start with a new topic in the next class. See you in the next class. Good day, everyone.